So, intersecting, the line of intersection between two planes. You want to find the vector equation of the line of intersection of plane that's given to you and a second plane. As I described yesterday, think of opening up your textbook. Okay, it's the line where the two pages meet in the middle on the spine of the book. We're wanting to try and find that line, the equation of that line. So once again, we're going to look at the notion of, if you think of the book on its side like that, okay, that's the line that we're wanting to pick up, the equation that we want to pick up. Now, if we get the normals to this plane, going that way, and going that way, so there are the normals to the plane. And imagine something running along there like that. What can we say about that line and this line over here? They're going to be parallel. They're not going to intersect, are they? They're going to be running in the same direction. Okay. So, in fact, if we can get this direction over here, that direction is going to be in the same direction as the one up top over there. And so we can get a, or can we get that direction? Okay. How?
Find 2 points.
Sorry?
Find 2 points on it.
Find 2 points in it. Yeah, that's possibly a bit tricky.
The perpendicular vector, both of them.
Yeah, the perpendicular to both of the normals, isn't it? Okay, if you think of it, we're wanting to get a line that's going to be at right angles to this. You think of the spine of your book. Okay, the book has got square edges. The spine is at right angles to the side of the book. So, yes, we're looking for that perpendicular to two vectors. And where are we going to, or how are we going to get that? What is the process that we did? Cross product, yeah. Okay, so let's try and get some cross products. So first of all, why did I talk about the normals and not just talk about those lines over there?
Because you don't have the directional vector.
I don't have the directional vector of that. What is the equation of the plane actually tell me?
No.
The normal. Okay, it gives you a normal to the plane, and that's why we're working with this normal. So once again, let's talk about normal 1. Normal 1 would be what? 2, 1, 1, correct? And normal 2 will be 3, 3, and -5. Good. So there are two normals. We find the modulus of those. Do we need to find the modulus of it? No, we don't, because we're not actually trying to find angles between them. We're wanting to find something that's at right angles to those two normals. So we need to do a cross product of these two vectors. So what are we going to get here? Cross out the first line. The x coordinate will be 1 times -5 minus 1 times 3. Go away. Go to the y coordinate, cross out the middle line. start at the bottom left, so I've got 1 times 3 minus 2 times minus 5. And then to get the bottom one, I'm going to say 2 times 3 minus 1 times 3. So what have we got now? We've got minus 8, 13, and 3. Minus 8, 13, and 3. So, what has that given us?
Position.
The
Direction.
the direction vector of that new line. So we know that we've got this line that's going to be r something plus t minus 8, 13, and 3. Question is how we're going to get points on that line. Point of intersection between planes.
That's the equation for the actual red line.
It's an equation for either that line or that line,
Oh, it doesn't not matter.
because remember you said they're going in the same direction, aren't they?
Oh, yeah.
So they've got the same direction vector. To be able to pin it somewhere in space, we need to find a point where they're together, right?
You just said that. Just put the values x, y, and z.
X, Y, and Z. Okay? That's a start, but I think we need to be a bit more specific than that. That's just in your line. Kevin?
For like z equals 0 and these simultaneous equations, something similar.
We could, yeah. What are we looking for? We're looking for a point where the two planes meet. Have a think about that. How we're going to get out. I think Kevin's on the right sort of track, rather like we did when we were looking for question 3 from exercise 12a. They asked you to find points A and B. Show that points A and B lying anywhere in the plane will have this normal on the way. Intersection point of the two normals.
Yeah.
You could,
So many.
but where's that going to be? It's to be somewhere along over here, wouldn't it? Be somewhere along that line,
Yeah.
and that's not really the line that I want.
Oh.
Yeah, that's the line that I want up there.
Oh,
Can we
right.
find the intersecting point like of the two planes, like one of the intersecting points?
Intersecting point of the two planes.
Do you
Interesting.
use a sort of simultaneous equation method where you eliminate one of the y or x or z
Of what?
of the two equations?
Equations of the planes. Is that what you're talking about, Wilson?
I'm not.
I think that's possibly what you're referring to. You're talking about your two planes. You want to know where the two planes are the same, aren't you?
Yeah.
Okay. So how are we going to do that?
Times the first equation by 3 and eliminate the 3y.
Okay. Let's see. Where are we? Here we are. So let me just rewrite these equations. 2x plus y plus z equals 8. And what you got? 3x plus 3y minus 5z equals 0. So Ray, you want to do which one, sorry?
Just times the first equation by 3.
3 or minus 3?
Oh, Yeah, it can be -3.
Okay. Let's take equation 1 multiplied by -3. We're going to get minus 6x minus 3y minus 3z equals minus 24. And then I've got the other equation, which is 3x plus 3y minus 5z equals zip. So now if I go and add those two together, I'm going to get minus 3x minus 8z equals minus 24. Well, that's kind of neat, isn't it? Because,
Divide the whole thing. Oh,
no, we actually can't. You saw the 8 and the 3 and thought, 24. Yes. No. So we're partly on the way. Kevin, how are we going to take it further from there?
Z in terms of x.
Come on, Kevin, don't let me know now. You had the idea earlier.
Still thinking of the
Yeah,
Oh.
because somewhere on the line, z must equal 0, doesn't it?
Oh, really?
Yeah. Well, I mean, think of it. If I've got, I'm just going to take it something simple as a straight line. Okay, maybe the origin's over there, but I'm dealing with this line over here. At some point, that line going carry on going. At some point, it's going to have an x value that's 0, and it's going to have a y value that's 0. Although I'm really only concerned with this part over here, if I extend it on far enough, I will find a point at some stage where one of those is correct. That's why we can take what Kevin's saying there. Which one do you want to take out, Kevin? Z. Okay, you don't like Z's. You're Zist. When Z is equal to 0, what have we got? We've got minus 3x is equal to minus 24, and therefore x is going to equal 8.
Y.
So let's go back then to in equation 1, we've got z is equal to 0, we've got x is equal to 8, and so therefore what have we got? We've got 2 times 8 plus y plus 0 is going to equal 8. And so y is going to equal minus 8. So we've got a point now. We've got a point that lies on both planes. It's the point 8 minus 8, 0. And it's a point where the two planes cross. Somewhere where those two planes cross, that point will lie on both of them. And that's neat, because that's what I wanted. I wanted this point over here in the equation. So let's just get that part a bit further down here. We said R was going to equal, we needed a point, we've got the point, plus T, and then the direction vector was -8, 13, and 3. Okay. So we got there in the end. Well done. We'll just see how we're building on sort of bits and pieces that we've worked on all the way through.